We're going to start with topic 1, and topic 1 was converting between degrees and radians. Again, if you have any questions, just type it in the chat and I will answer them. So, to convert between degrees and radians, okay? So, to go from degrees to radians, you have to multiply by pi over 180. So you guys should be making a review sheet if you haven't already. This would kind of go in that notes section that's there. So to go then from radians to degrees, you have to multiply by 180 over pi. So it's the flip of this fraction there. So we're going to do an example of each. If you have any questions, just type it in the chat. So here's the first one. So it says convert the following angle from degrees to radians. So we have 210 degrees, and we want to convert that to radians. To do that, we have to multiply this by pi over 180. If you'd like, you can treat this as 210 over 1. So when you multiply that, we get 210 pi over 180. This is not in simplest form yet. You have to simplify that fraction. To simplify the fraction, you have to use your calculator. I don't think you'll be able to see my calculator. Can you guys see me on the screen? Like if I use my calculator like this, can you see my calculator? Can someone just text in the chat yes or no? Or not? Okay. All right, good. So what you want to do is you want to do 210 divided by 180. You could do it just like that. Press enter. You don't want a decimal. To get it back into a fraction, just press math frac, and it becomes 7 over 6. So this simplifies to 7 pi over 6 radians. Notice I did not type the pi in my calculator. The reason I didn't do that is because it wouldn't give me a fraction if I did. We need pi in our answer, so you don't type pi in your calculator. Okay, so for the next one, again, if you have questions, just ask in the chat. It says convert 11 pi over 12 radians to degrees. So to convert to degrees, we multiply by 180 over pi. Now you know you're using the right conversion if the pi's cancel out. Since this one is in the numerator and this one is in the denominator, they will cancel out. And then we multiply across. So we have 11 times 180, which is 19,080. And then we just have 12 in the denominator. And then you divide. When you divide these two, we get 165 degrees. So this right there is the degree version of 11 pi over 12. Any questions on that? If you have any questions, just ask. If not, we're going to get to topic 2. So topic 2 are our trig ratios and our reference angles. So for the trig ratios, we use SOHCAHTOA. Okay? This helps us remember the sine, cosine, and tangent ratios. So sine, you find that ratio by doing opposite over hypotenuse. Cosine, you find by doing adjacent over hypotenuse. And tangent you find by doing opposite over adjacent. Now there are some reciprocal trig ratios. The reciprocal of sine is cosecant, okay? So to find cosecant, you can either find the sine and flip that fraction, or you could do hypotenuse over opposite. So you just flip that fraction. The reciprocal of cosine is secant, and that would be hypotenuse over adjacent. Again, just find the reciprocal or the flip of that fraction. And the reciprocal of tangent is cotangent, and we'd have adjacent over opposite. Now I do want to talk about the parts of the triangle because I think some people get it confused. So here's our right triangle. Let's say we're looking at angle A. This one right over here. The hypotenuse is always the easiest to identify because it's the same in every triangle. Okay, it's that slanted side. Now, the adjacent side, adjacent means next to. So this right here is your adjacent side. And opposite is right across from that angle. So that would be the opposite. Okay, so that's the parts of the triangle in case that confuses you a little bit. All right, now, next thing we're going to look at is reference angles. There are rules for the reference angles. Just going to make a little line here. So first thing you want to do when you want to find a reference angle is draw the angle, okay? So first, draw angle. You want to know what quadrant it's going to fall in. And then after you draw the angle, you just use this rule. So here's our coordinate plane. Now you need to know the degrees of this. So it starts at 0 degrees, then it goes to 90 degrees, 180 degrees, 270, and 360. So you're going to need to know these degrees in order to draw where your angle is. If your angle falls in quadrant 1, your reference angle is just theta. That's your angle. If it lands in quadrant 2, your reference angle is 180 minus theta. If it lands in quadrant 3, your reference angle is theta minus 180. If it lands in quadrant 4, your reference angle is 360 minus theta. Okay, you just need to know those 4 rules. So we're going to get to some examples now. All right, so first example we're going to practice with the trig ratios. It says, in this triangle, what ratio represents the tangent of angle J? So we're actually going to find all 6 trig ratios of angle J, just so we have the most practice. So here is our angle that we're looking at. So we're going to start with the sine. So let's find sine of J. So using SOHCAHTOA, I'm going to write that up here. If we're looking at sine, we want opposite over hypotenuse. So the opposite of J is 11. Oh, hold on. So the opposite of J is 11, and the hypotenuse is 61. Now you want to see if you could simplify this at all. So in your calculator, you could type in 11 divided by 61. Press Math Frac. If you get a simpler fraction, change it. In this case, you do not. So it just stays sine of J equals 11 over 61. Now let's find cosine of J. For cosine, we use ca, so adjacent over hypotenuse. The adjacent side is 60. The hypotenuse is 61. Again, if you can simplify it, but in this case, we cannot simplify it. And then lastly, we are going to find the tangent of J. So tangent uses the opposite over the adjacent. Opposite side is 11. Adjacent is 60. Now we're also going to practice with the reciprocal trig functions. So the reciprocal of sine is cosecant. So the cosecant of J, you just flip this fraction. You get 61 over 11. The reciprocal of cosine is secant. So the secant of J, when you flip this, gives you 61 over 60. And then the reciprocal of tangent is cotangent. And when you flip this fraction, you get 60 over 11. So those are the 6 trig ratios of this triangle. Again, the question only asked for tangent, so you only needed to find tangent. But since this is a little bit of a review, practice finding everything. Okay? Moving on, we'll practice finding a reference angle. So it says find the reference angle for the rotation of 135 degrees. So I do want to see where 135 is. So I like labeling these the different degrees. So that's what I'm going to do. Now 135 degrees is somewhere here in quadrant 2. Okay, because it's between 90 and 180. So the rule for quadrant 2 to find the reference angle was 180 minus theta, where theta is your angle. So you have to do 180 minus 135, and 180 minus 135 is 45 degrees. So that right there would be our reference angle. If you have any questions, just type it in the chat and I'll refer to them. All right, finding a trig ratio from a point. I'm going to write the steps down. So the first step here would be to plot your point. Okay, you need to know where that point is on the coordinate grid. Your second step would be to make the triangle. You can be more specific if you want, so you could say connect the point to the origin and then connect the point to the x-axis. Your third step would be to label the triangle. So to label the triangle, your horizontal distance is your x-coordinate, your vertical distance is your y-coordinate, and then lastly, you find the trig ratio they ask for. So find trig ratio, and you can't forget to use all students taught constantly to figure out if it's positive or negative. So we're going to do one question with this. So it says angle theta is an angle in standard position and its terminal side passes through this point. Find the exact value of secant of theta in simplest radical form. So first let's find out where that point is. So the 0.49 is somewhere in this first quadrant. Again, you don't have to be specific, it doesn't have to be exact, but you need to know which quadrant it's in. Since both x and y are positive, it's going to be in the first quadrant. So to make your triangle, connect your point to the origin, and then connect your point to the x-axis. The right angle is made from that point down to the x-axis, and your angle theta is made with the x-axis as well. Okay, so let's label our sides. So our horizontal distance, that's our x value, so x is 4. Our vertical distance, that's our y value, y is 9. Now in this case, both of them were positive, so it didn't really matter, but if one of your coordinates were negative, on your triangle, you can't have a negative distance. So all of them have to be positive. To find the hypotenuse, we have to use a squared plus b squared equals c squared. Okay, you have to use the Pythagorean Theorem. A and B are your legs of the triangle. C is your hypotenuse. So we're looking for C. So we have 4 squared plus 9 squared equals C squared. We're looking for C squared. So 4 squared plus 9 squared. This whole side gives us 97. So 97 equals C squared. So we take the square root of both sides to cancel out the squared. And we get radical 97 equals C. So the hypotenuse here is radical 97. So now we use this information to find the secant. So the secant is the reciprocal of cosine. So what I suggest doing is first finding cosine. If you don't need to do this, you don't have to. So cosine is adjacent, which is 4, over the hypotenuse, which is radical 97. Now it wants the secant, so the secant is just the reciprocal of that. So the flip of the fraction. So radical 97 goes in the numerator, and 4 goes in the denominator. Last step is to use all students talk constantly. The triangle is with the A. That tells you that all of your trig ratios are positive. So this should be a positive answer. Something you should get into the habit of doing, because Delta Math will mark you wrong if you don't do this, is simplifying the radical. So to simplify a radical, what you have to do is see if a perfect square goes into the number that's underneath. Now, there is no perfect square that goes into 97, so we can't simplify this anymore. But if you can, you should. So this right here would be our answer for secant. I do want to talk about one more thing. Delta Math, let's say you had to find the cosine and you had this answer. If you type this into Delta Math, it will mark you wrong. Reason being is it's not rationalized. That means that there is a radical in the denominator. You can't have that. So to rationalize your answer, so you rationalize when you have a radical in denominator. So we had 4 over radical 97. To rationalize this, you multiply the numerator and denominator by radical 97. When you do that, in the denominator, you're just left with 97. The radicals go away. And you have 4 times radical 97. So if Delta Math asked you for cosine, this here would be your answer, not the original one. It would mark this one wrong. That's why you have to rationalize the denominator. So again, any questions, just write it in the chat. Moving on to the next topic, which is the unit circle. So for the unit circle, it's practically exactly the same as the topic before. I do want to talk about one rule that you have in the unit circle. When you have x, comma, y, okay, on the unit circle, this is your cosine theta, comma, sine theta, okay? One other important part of the unit circle is that your hypotenuse is always 1. Right, those are the 2 important pieces of information from the unit circle. So let's get to a problem. So it says the point P lies on the unit circle shown below. The fact that it's a unit circle is very important. What is the value of y in the simplest form? So it tells us that P is right over there. That's important because it tells us that it is in the 4th quadrant. We are going to use that. When you're given a point, you should always draw your triangle. Okay? So there's our triangle. We draw a point to the origin and we drop it to the x-axis. Now this point, they told us, is radical 33 over 7, comma y. So this x value here, the horizontal distance, is radical 33 over 7. The vertical distance is y, because we don't know that, but the hypotenuse is 1. So this helps us because we can use the Pythagorean Theorem to find y. So we have a squared plus b squared equals c squared. Now we know c is our hypotenuse, and a and b are your two legs. So let's say a was a radical 33 over 7. Let's leave b as b, because that's what we're looking for, the y. Actually, why don't we change it to y? So this will be radical 33 over 7 squared plus y squared equals 1 squared. And then we simplify. When you have this squared, that squared goes to the numerator and it goes to your denominator. So I'm going to take an extra step to split it up. You obviously don't need to do that if you don't need it. 1 squared is 1. Now we simplify. So the square root of 33 squared, those two cancel. We're left with 33 over 7 squared is 49 plus y squared equals 1. We're just solving for y, so we have to subtract both sides by 33 over 49. So 1 minus. When you type this in your calculators, you always want to use the alpha y equals button. Okay, that is always highly, highly suggested. So that will cancel out, and we're left with y squared equals 16 over 49. We don't want y squared, we want y. So you have to take the square root of everything. So you take the square root of the numerator, square root of the denominator. So luckily, the square root of 16 is just 4, and the square root of 49 is 7. So y is equal to 4 over 7. Now, if you type this into Delta Math, you would be wrong. Because it is in the fourth quadrant, y is negative here. So this should be a negative 4 over 7. So that is our y coordinate. Okay, so again, if you have any questions, just type it in the chat. And we are going to move forward to the last topic, which is Pythagorean Identity. After I go through this, you will be open to have any questions that you may have. So the Pythagorean Identity is sine squared theta plus cosine squared theta is equal to 1. Usually this is given to you, but in case it's not, this is the Pythagorean Identity. Now, the way you use this is they'll give you a sine or a cosine. You plug that in, and then you solve for the other trig function. Okay, so if they gave you cosine, you'll solve for sine. So why don't I write the steps here? So plug in what they give you. Then you have to solve for other trig function. And then they might not ask you for sine or cosine, they might ask you for tangent or secant. So just answer the question that they give you. But you have to keep in mind, all students talk constantly. You need to know if your answer is going to be positive or if it's going to be negative. So moving to a couple of examples, we're going to do 2 examples of this because there's 2 different types of questions. So here is the first. So it says using the identity, so they tell you to use it. Find the value of tangent of theta, that's what we're looking for, to the nearest hundredth if cosine of theta is equal to that. And then they give us this over here. I want to talk about this for a second because that confused some people on yesterday's lesson. I got some emails about it. So what we're used to is, I'm going to erase this, is 0, 90, 180, 270, and 360. Okay, we're used to using degree measures. What they gave us is radian measures. So we can use radian measures when we do this. 0 stays as 0. 90 can be written as pi over 2. 180 can be written as pi. 270 can be written as 3 pi over 2. And 360 can be written as 2 pi. So what they're telling us here is our angle theta is between, so our angle is between pi over 2, which is 90 degrees, and pi, which is 180 degrees. So it's saying that it's over here in quadrant 2. So instead of telling you the exact quadrant that it's in, it's giving you a little bit extra. So we're in quadrant 2. We'll just leave that there, but I am going to erase this work in the middle. Okay. So, getting to the problem, it says using the identity, so that's what we have to use. We have to use sine squared theta plus cosine squared theta equals 1. We don't know sine, but we know cosine. So sine squared theta plus, we're going to plug in cosine, which is negative 0.42 squared equals 1. And then we simplify. So negative 0.42 squared. When you type it into your calculator, make sure you have parentheses. You get 0.1764. So sine squared theta plus 0.1764 equals 1. Solve for sine. So we subtract this on both sides. So minus 0.1764. This cancels out. We get sine squared theta equals 0.8236. And the last step would be to take the square root of both sides. So you want to get rid of that squared. So we are left with sine theta is equal to, we have 0.90752. I'll stop it there. Now, I'm not going to round at this step yet because we don't want the sine, we want the tangent. So I always like rounding at the very, very end because you don't want to make a rounding error. So the way we find tangent is tangent is equal to sine divided by cosine. Okay? We're given decimals, so we can divide decimals. If you were given a fraction, I would suggest, don't copy this down, but if you were given 2 fractions, I would suggest writing it like, say, what's going on? Oh, there we go. let's say you had 2 over 3 divided by 4 over 6. I would suggest writing it like this, not writing it one fraction over the other. That can get very confusing, and we don't want to confuse you. Okay? So, we're given decimals, so we're just going to write it right in. So, tangent of theta is equal to sine. Sine was equal to this. So, 0.9075, can I squeeze it in there? 2, divided by cosine, which was negative 0.42. Oh my goodness. So negative 0.42. So tangent of theta is equal to 0.42. So this is a negative 2.16077. Okay, so now is when we're going to round to the nearest hundredth. The nearest hundredth is the second decimal point. So we're rounding it to the 1 that's squeezed in over there. So it would be negative 2 point, sorry, not the 1. What am I thinking? We have to, oy, oy, oy. I'm clearly not very good at this stuff, but I'm really trying. 1, 6, 0, there you go. So rounding it to that 6, not the 1, because it's the nearest hundredth. So when we round to the 6, we look at that 0. Since the 0 is below 5, it stays a 6. So negative 2.16. Now it is negative. If we were to use all students talk constantly, we were in the second quadrant. So the second quadrant, only sine is positive, so tangent should be negative. So this right here would be our answer for that. Okay? So we are going to go through one more example of this. We're going to be using fractions. So I'm going to go to that example now. So now we have some fractions and radicals, everyone's favorite. So we have sine of theta is equal to radical 35 over 6, and they tell us that it is in quadrant 1. What is the exact value of cosine of theta? Now, in this case, it doesn't tell you to use the Pythagorean identity, but that is the best way to do this problem. So they give you sine, and they want you to find cosine. Exactly the Pythagorean identity. So, sine squared theta plus cosine squared theta equals 1. Now, if you are working on your review sheet right now, these are very good examples to include on there. If you already gave it in, that's fine though. Okay, so they give us sine of theta, so we're going to plug that in. So radical 35 over 6 squared plus cosine squared theta equals 1. That squared is applied to the numerator and to the denominator. So it's radical 35 squared over 6 squared plus cosine squared theta equals 1. When we simplify this, oh, we want another minute. So when we simplify this, the radical and the squared cancel out. So we're left with 35 over 36 plus cosine squared theta equals 1. And now we solve. So to solve, we subtract 35 over 36 on both sides. When we do that, that will cancel out. and we will be left with cosine squared theta is equal to 1 minus 35 over 36 is 1 over 36. Again, you would type it in your calculator. So if you have trouble with typing it in your calculator, this is how you would type it in. You can see that. 1 minus alpha y equals 35 over 36. And it'll give you 1 over 36. Last step is to square root everything. So you square root the numerator, square root the denominator. The radical and the square will cancel. And we're left with cosine of theta is equal to, the square root of 1 is 1. Square root of 36 is 6. So you have to use all students taught constantly. It tells us that we are in the first quadrant, I believe. Yes, it says we're in quadrant 1. In quadrant 1, all trig ratios are positive. So our answer is just 1 over 6. Okay? So that's all the examples that I have to go over because I wanted to get through one of each. So now I'm going to stop sharing the screen and then you can ask whatever questions you would like. So ask in the comment section any questions you may have. So anyone have any questions? Yes, no, maybe, so, questions? Those of you who just joined, I just finished the review. But if you have any questions, I'll answer them here.
Miss, how do you do the talking thingy? Like, how do you chat? Because I can't do it.
There should be a chat box on the top that you have to click.
How
How
do you do since I'm already talking, how do you do that? What is the SA, all students talk constantly? What does that do?
Okay. So all students talk constantly. Can you still see my screen, the Smart Notebook being shared?
Yeah.
Okay. So that tells you what trig ratios are positive in which quadrant. So it goes A, S, T, C. So in the first quadrant where it's an A, that tells you that all ratios are positive. In S, in the second quadrant, that tells you that sine and its reciprocal, which is cosecant, are positive. The rest are negative. So rest are negative. In the T, that tells you that tangent and cotangent are positive. And the rest are negative. And with the C, that tells you that cosine and secant are positive, and the rest are negative. So this is the fourth quadrant, and this was the third. So let's say you were looking for the sine of an angle in quadrant 3. So you're looking for the sine of this angle. Since it's in quadrant 3, the sine is going to be negative. That's it. So it tells you which is positive, which is negative in every quadrant. So anyone else have any questions? If you want, you actually can unmute yourself and then ask. Can you please show the different forms of angles from the first example of topic 5? What do you mean by that, Isis? So the first example of topic 5, this one? Oh, you mean this part here with the pi over 2? Okay, so yeah. So I'm going to do that on a separate slide. Now, so that tells you what quadrant to look at, but instead of giving degrees, it gives radians. So this is usually 0 degrees. I'm going to do degrees in red, radians in blue. This is 90 degrees. This is 180 degrees. this is 270 degrees, and this is 360. So this is what we're used to, but Delta Math likes using radians. So 0 degrees is the same thing as 0 radians. 90 degrees is pi over 2 radians. 80 degrees is pi radians. 270 is 3 pi over 2 radians. Bye, Remy. And 360 is 2 pi radians. So the question might tell you that it's in, they'll say like pi less than theta less than 3 pi over 2. That's just telling you that the angle is between pi, which is 180 degrees, and 3 pi over 2, which is 270 degrees. So it would be in quadrant 3. Does that answer your question, Isis? Okay. All right, anybody else have any questions? You can unmute yourself or type it in the chat.
Can you go through all the questions you did? Not like go through them, like can I just see it so I can see what the questions you did, because since I came late?
Yeah. I'll scroll back. So we did converting between degrees and radians. We did trig ratios. I am going to post this video up so you can go through each one. We did reference angles, trig ratios from a point, the unit circle.
Can you go over topic 1?
Topic 1, yeah. So I'm going to be uploading this to YouTube as well, but I'll go over it quick. So for topic 1, it's converting between degrees and radians. So to go from degree to radians, you multiply by pi over 180. To get from radians to degrees, you multiply by 180 over pi. I'll do some other examples other than the ones that we just did, so I'm going to go to the back. Grizel, there are going to be 13 questions on the test. So let's say, if you watched the video I posted yesterday, I said there were 13 questions. I said it was very important, please watch. Melanie watched it. She commented on it. So let's say we had 310 degrees and we wanted to change this from degrees to radians. So what we would do is we would multiply it by pi over 180. So we could treat this as 310 over 1. Then we would do 310 times pi, which is 310 pi. And then 1 times 180 is just 180. So you would simplify just the numbers, not pi. So to do that in your calculator, you would type in alpha y equals, and then 310 over 180, or you can use the math frac button, and it'll simplify to 31 over 18. So it'll be 31 pi over 18. And that would be your answer in radians. Now let's say we had 4 pi over 5 radians, and they asked you to convert it to degrees. You would multiply by 180 over pi. You know you're doing this right because these two pi's cancel out, because one's in the numerator, one's in the denominator, and then you multiply straight across. So 4 times 180 is 720. And 5 times 1 is 5. And then you would do 720 divided by 5, which gives you 144. So this is 144 degrees. So that's topic 1.
Is there any way that, let's say, if you got like a different number that wasn't divisible by 5, it can't be a decimal, right? Like, if you know you're doing it wrong if it's a decimal?
Yeah, I would leave it as a fraction. If you get a fraction, leave it as a fraction. I wouldn't convert to a decimal.
But do you put it as degrees as the fraction?
Yeah, so let's say you got 12 over 15 degrees. You would have that degree symbol there.
Okay.
Any other questions? Nobody? Alright, I'm going to stop screen recording my screen, so this is what's going to be posted on YouTube.